All right, welcome. So today, we're going to dig into something pretty fundamental, a critical look at a cornerstone of modern physics, the tensor. Now, tensors are basically the mathematical language of general relativity. But what if that whole language is built on a fundamental flaw? So the source we're looking at for this is a paper by Mathis, and it kicks off with what seems like a simple question, but it quickly spirals into a really deep critique of the physics establishment. Okay, let's dive into this.
So first up, a simple question. Why tensors? The whole investigation starts right where you'd think it would, just looking for the official reason, the justification for using tensors in general relativity. I mean, why was this specific mathematical tool chosen to describe the universe?
And what the source finds is that the official answer is, well, surprisingly tough to pin down. And when you do find it, it's even harder to make sense of. The author zeroes in on one specific paragraph from the Wikipedia page on general relativity. And he argues, this is the perfect place to start poking holes, because these pages are pretty heavily policed by universities and basically represent the mainstream consensus.
All right, let's move on to deconstructing the official answer. So what does the official story actually say? We're going to look at the exact text the source is critiquing, and then we'll break down the argument point by point to see exactly why the author finds it so, well, unsatisfying.
Now here's the thing. The source argues that this entire paragraph, which is supposed to answer why tensors, does pretty much everything except answer the question. It throws around a lot of impressive-sounding words like covariance and invariance, but the critique is that it's all just circular logic and a bit of misdirection. Let's see how. So the source basically breaks this down as a chain of misdirection. First, it brings up covariance, the idea that the laws of physics should look the same no matter how you're moving. But the critique is, hang on, that's just the old principle of relativity from special relativity, and that theory didn't need tensors. Then it introduces other confusing terms, only to kind of brush them aside. And finally, it learns on this piece of circular logic, basically saying general relativity uses tensors because it's built on a type of geometry that, well, uses tensors. It's kind of like saying I speak English because I use words from the English language. It doesn't actually explain anything.
Okay, next up, relativity's apparent contradiction. This is where the source tackles what it calls a really astonishing contradiction, right at the very heart of the tensor concept and how it's used in relativity. And this isn't just about confusing words anymore. This is about a potential logical impossibility.
So here it is. This is the core of the problem, according to the source. Just look at these two statements. On the one hand, the definition of a tensor is that it's independent of your frame of reference. But on the other hand, the entire point of relativity, the first principle, is that nothing is independent of your frame of reference. Your measurements of time, of space, of motion, they all depend on your perspective. The whole game of relativity is about transforming measurements from one frame to another, which is the very definition of dependence.
And this quote from the source, Mathis, just illustrates it perfectly. It's like saying, my body needs oxygen to live, except for my legs. You can't have it both ways, right? How can you have a theory that's fundamentally based on everything being relative, but then use a primary mathematical tool that is supposedly independent of it all? It's a huge contradiction that the source claims is just glossed over.
But the critique doesn't just stop there with the language and the logic. It escalates to what the source identifies as two fundamental flaws in how tensor fields are actually applied to the physical world, to reality itself.
So this first flaw is something the source calls a dimensional divorce, and it's a really interesting idea. Think about a single point in space, just a location. Physically, it has 0 dimensions. It's just there. But in the math of general relativity, a single point in a tensor field isn't simple at all. It's an incredibly complex object that, according to the source, needs at least 6 different numbers just to describe it. Things related to its position in space-time, its curvature, its motion, you name it.
So the conclusion here? Well, the source argues that you just can't do it. This dimensional mismatch makes it pretty much impossible for the math to properly connect with the physical world it's supposed to be describing. You can't just place a real-world object into a mathematical space that is already orders of magnitude more complex than the object itself.
Okay, that brings us to the second foundational flaw, and this one involves the very nature of the field itself. Look, to measure anything, to do any kind of physics, you need a stable, reliable background. The source calls this a homogeneous field. Think of it like a perfect, unchanging grid, or a solid stage to perform your experiments on.
But here's the problem. Tensor fields in general relativity are defined as varying from point to point, and the author argues this is a huge logical contradiction. A fundamental field, the very fabric of space, can't be arbitrary and constantly changing. The analogy used is perfect. It's like trying to measure a room with a ruler made of elastic. How can you get a reliable measurement if your measuring tool is always changing?
So, this leads us to the crucial point. If these critiques are valid, what are the actual consequences for physics? According to this source, these are not just some philosophical arguments. They are the root cause of some of the biggest problems in cosmology and particle physics today.
The source really connects the dots here, claiming that many of the biggest mysteries in physics are actually just symptoms of this broken math. You know, things like singularities, that impossible point of infinite density at the center of a black hole, or the need for these mathematical patches like renormalization to fix equations that keep giving infinite answers. The argument is that these aren't features of our universe, they're bugs in the code. The math is disconnected from reality, so of course it eventually breaks. And that's our look into this critical source on tensors. The author really leaves us with a provocative question, doesn't he? Has physics become so lost in its own complex equations that it's forgotten to check its own premises? The suggestion is that the path forward isn't more math, but actually clearer thinking and better definitions. Definitely a challenging thought to end on.